17.
Your work is detailed enough to prove you fully understand the activity and learning goals.
You've got this. You kept at it. You asked questions if you didn't understand. You looked for ways to make your work better. You corrected errors. You used all of your time to keep getting better.
Page 28, 29.
Should we be showing them what it looks like?
Try and keep it all in one video.
Yeah.
If you need to pause it, just keep the, replay it to do the video. Okay, looks like everybody's done. Take a look at number 1. So this is where we're going to write our hypothesis. So what variable will you investigate? I want you to list the independent and dependent variables. So I've given you a starter over here. I want you to write it in these terms. If, fill in the independent variable, then fill in the dependent variable. So for example, I could say, if I raise the height of the marble that I dropped from, then we will see the crater depth increase. Does that make sense? So that's just one example of an independent variable that would have an effect on a dependent variable. Talk with your partner about which independent variable you want and which dependent variable you think it will have an effect on. Pick one for each. Copy this down in the sentence structure. Ready, go.
What independent variable do we want to use? I think one big one that we can really pay attention to is like the height we dropped the marble from.
We did that yesterday, didn't we?
Yeah, but this time we're gonna record it. Yeah.
Okay. Yep. Can we do the way that it goes and spin it? I guess. Oh, never mind. The only way that you can do that is only if you spin it.
Speak loud, they can hear you. Okay.
I feel awkward if I scream.
I know. Okay, so we'll write if we change the height that we dropped the marble from, then what will change?
How deep the craters are.
Okay.
The rays.
Mm-hmm.
Okay, I need you to self-monitor here. I need you to check for, is my independent variable measurable with numbers? Is my dependent variable measurable with numbers? All right, so let's talk about some generalities, okay? With your independent variable, if you're talking about increasing the size, is anybody increasing the size for their independent variable? You guys are? How did you word it?
The size of the marble changes, then the curve width will be larger.
Great. Okay, this is a perfect example. All right. We're going to look at your thing. I want it to be more specific. So what do you mean by size for your independent variable? What are you going to measure? So if the diameter of the object changes. Okay, that's what I want you to write. If the diameter of the object changes. So for example, if you go from one of these marbles here to this here. Yeah? Is that what you mean? Okay, great. And then let's talk about your dependent variable. You said the crater will get larger. What are you going to measure? So you're going to measure the diameter of the crater, the width of the crater. Great. Go ahead and change that. Make it that specific. All right. Can I hear yours, please?
Yeah. We said if we change how high we drop the marble from, then the crater depth will change.
Okay, so you got height and depth to measure things. How about you guys?
We did the
Exact same thing. Gentlemen?
If you raise the height of the marble, then the crater would get
Deeper. Okay, how about you guys?
If we raise the height, then the marble will fall faster.
Okay, so don't we want to see how it will affect the crater? Though, isn't that what we are investigating? Yeah. So we change the speed. That is the independent variable. We change the speed. The process we use is to raise it up. So that's still your independent variable. Now, what's your dependent variable going to be in terms of the crater?
It'll get wider, more deeper.
You can do wider, or you can do deeper. You know what I haven't had anybody do that you may consider, gentlemen? I haven't had anybody measure how far the ejecta travels. That might be something to consider too. Please talk with each other and figure out which one of those dependent variables you'd like to do and change. How about you guys?
We had if we raise the height we drop the marble from, then the degrees will be further and the crater will be.
Ah, okay, so you are doing how far the ejecta will go. Okay, use that vocab term, but you have two dependent variables. You got to choose one, because we're only going to look at one. So talk with your partner and think, do you want how far the ejecta goes, or do you want how deep it's going to be? Ladies, you already did yours, didn't you? Okay, and how about you guys?
If the diameter of the object is bigger, then the raise will be longer.
The rays will be longer. Okay, I'm going to ask you to change that to the ejecta will travel farther, because sometimes our rays are going to go onto the carpet. Special consideration for people who are measuring ejecta. You got to find an area of the carpet that's relatively clean so that you can see your farthest spot. Videotaping and referring to the videotaping may help you so you can see the farthest spot out, and you guys will want to use the cocoa powder. Everyone else, you don't need to use the cocoa powder today. Make sense? Okay, so make those changes on number 1. Is everybody ready? Yeah? Okay. I want to take a look at how you want to record things. Okay? So I think number 3, yeah, number 3, what will you measure? So talk with your partner about if you want to do what sort of measurement you're going to use. So what sort of measurement will you use for diameter? What sort of measurement will you use for height? What sort of measurement will you use for distance? What sort of measurement will you use for depth? I'll give you about 30 seconds. Go ahead.
For height, we're gonna use meters
Okay.
because yesterday when we did it from all the way to the ceiling.
And that was.
It was like 2.38 something meters.
And then, what about the depth of the crater? Meters too.
I guess, yeah.
Okay.
Can we go on the whole?
Okay, come back to me. Ready? Thank you. All right. So take a look at question number 4. Question number 4 says, how will you record your data? And how many trials? All right. So we're not writing anything quite yet. I just want to talk about it. How are you going to... Let's first talk about how many times do you want to change your independent variable? So if you are going from, if you're doing height and you start at 0.5, how many times are you going to change it after that? Talk to your group and then raise fingers and tell me.
I think we should go by 10.
I think so too. 10.
Okay. Wait, how high are we gonna go?
So 10 tries.
So we're gonna go to
Okay, I see 10. I see 5. I see 5. I see 5. I see 4. I see 6. What do you guys have? 4 or 5? 4 or 5. Okay. How are you guys? 5? Okay. I'd say 5 sounds reasonable. 10 is ambitious for the time we have. Normally in a scientific study, I'd say, yeah, do as many. For height, you could go by 10 centimeters, you know, until you get to 2 meters or whatever. But maybe you want to aim for like half a meter, 1 meter, 1.5, 2 meters, 2.5. Might be a good thing. 5 sounds great. Okay. Now, talk to your partner about how many trials you want to run at each independent variable. Go ahead. Hold up fingers when you're done.
2 or 3.
Let's do 3.
3?
We hold our fingers.
She asked if she needed help.
Sorry.
I see 3, I see 2, I see 3, I see 5, I see 2, I see 2. Okay. I'm going to encourage you to do 5 or more. Okay. 2 and 3 is a little light. You could get away with that, but there's a lot of stuff that happens where 1 or 2 trials are just completely off for no particular reason. At the end of it, we're going to average our trials so we got one number. Make sense? Okay. Now I want to talk about how to record our data. Go ahead and flip to page 30 and 31.
Can you hold up to show?
Oh. Okay, so this is 30.
If you look at those 2 pages,
That's 31.
they give you a data table that you could use. Okay, so you see they set up their independent variable on the left-hand side. There we go. They set up their independent variable on the left-hand side, and they change it. Okay, you guys said you wanted to change it 5 times. That'd be fine. Okay, they set up 3 trials and an average. I said we probably need 5 trials. So what I want you to do, okay, is create a chart based on your independent variable that's similar to this, okay? So you can do your dependent variable here. You say what it is. That's what it is having an effect on. Your independent variable, what do you think goes in the parentheses? Yeah?
The measurement you use.
The measurement you use, yeah, meters, centimeters, grams, things like that, okay? Perhaps the back side of page 29 or 30 would work well, okay? That's where you'd like to set up your data table, all right? If you put your units here, you don't have to have units for all of these. Go ahead and work on a chart now.
So we're gonna want to write our dependent variable at the top there. which is going to be crater depth. What's the date? The 13th. Yes. Independent. So it's going to be measured in meters.
Make sure you add a column on for your average. We'll take care of that tomorrow. Today we're data collecting. And we'll do some averaging and analyzing tomorrow. I mean Monday, sorry. Hopefully not tomorrow. None of you are coming back tomorrow, right? Happy weekend? Okay. Go ahead and put what your dependent variable is and what your independent variable is. Make plans for it now. If you haven't measured diameters, you're not going to know yet. You'll need to prepare for that. But you can put down what your independent variable is, and you can put down what your dependent variable is. Independent is what you're changing.
So bad.
Dependent is what you're figuring out.
Should this be the diameter of all of
Yep. Because this is your dependent, and that's your independent. So your independent will make those changes.
Yeah.
And then your dependent will find out what it will do.
So we'll put this at the top.
Oh, do we need to explain what we're doing? Okay, so she has a Google document that has this on it, and it has a column for average, independent variable, and then trial 1 to 5. And then on the downside of it right here, you put first, second, third, and fourth. And then I don't know what yours is. Have you already had science? Oh. Why am I asking you? I was gonna play, and I saw how big it was.
This is right. We have to measure the diameter of the balls. Can we go grab that?
Oh, we'll get there. Do a homecoming Kool-Aid when you're done. When you're done.
I'm just gonna record you guys waving.
Yeah, there is. I've got other things too.
I look like a mermaid. Or like one of like those hula girls who just like. Yeah. You know, I look like a dweeb. Always. This is just insulting Kaylin.
Yep. Mikey.
Happy Friday the 13th. You're getting it. We've already had 20 minutes of class. Don't get me coughing.
This video is gonna be like 45 minutes long.
Well, that is how long our class period
I
is.
know, but I have to sit here with the camera for 45 minutes.
No?
You can go back.
I'm getting tired.
Actually, I can do that. What?
Is your arm getting tired?
Oh, I should have hands today.
Okay, what is your independent variable?
The height.
Go ahead and say height. And then you can go ahead and decide now what your height is going to be. How are you measuring that? Meters or centimeters?
Meters.
Okay, go ahead and put an M there. And then you can put M's in these little parentheses here.
I thought we're going by half centimeters or half meters.
It'll be measured in meters, yeah. So you can do 0.5 for number one for your first. Nope. Erase that. At 0.5 meters, you're going to do 1, 2, 3, 4 trials. 5 trials. You don't have a column for averaging? Oh, great. This is where you put your units. This is where you put your heights. Okay, so you can do 50 inches, this many inches, this many inches, this many inches. This means you're going to do 5 drops.
What'd you just do?
5 drops at 60 inches, whatever it is.
5 and 2 meters. Okay, so we did 2 meters yesterday, didn't we?
Yeah, but you still got it. So this time we're going to record it. So
Okay,
you should have the first time 0.5, 1
Yep.
meter, 1.5, and 2.
Oh, you're explaining it to
One
them.
thing I'd
Should I
like
show
to
them?
say.
You can show them. You know, I say them like I have like
I
no
want to talk
idea.
to you about measuring strategies. For those of you doing diameters, I'd like you to do the diameter like we did the diameter of our globes. Remember that? Flap it here, measure across. That will work just fine. And is anyone doing mass? I don't think so. No? Okay. For height, I'm going to encourage inches to switch over to the metric system. Yeah? Because those numbers are going to be a lot easier to deal with. Imagine averaging in inches. You'll have to find a fraction. Ugh. Okay? So switch over to the metric system, please. In terms of measuring depth, when you drop a crater in, it's hard to get a whole, ruler in it to see how far down it goes. Here's my advice. Take a pen or a clean finger and drop it down next to, and then I can measure that depth. Make sense? Okay, and then for each trial you can just clean it off. Go again. Okay. Same for diameter. Take a pen, lay it across the hole, do a finger. Okay, it's right there. Measure that instead of trying to fit the whole ruler in there. Make sense? Okay. For height, this is another reason why I'm having you switch over to the metric system. Okay. It's easier to add those tens up because our meter sticks stop at 38 inches, 38 and a quarter inches, something like that. Okay. So for your meter stick, it will be a lot easier to be like, okay, a meter is 100 inches, and then I just add however many centimeters onto that. It'll be quite a bit easier to measure that. Make sense? Okay, please fill out page 29 with all the information that we discussed. For how will you record your data, number 4, you can just say, see the backside of page 29. Please talk about what you're writing.
What? Yeah, talk about everything. See back page of what page was it?
29.
Back page of 29 is not this. Did I do it on the wrong page? Oh, yep. Okay.
That's okay.
So
Just
back
put-
page of 30.
Okay, so how are we going to record our data? So we are going to use the meters for our measurement. And then we will record how far we dropped the marble from, and then how deep the crater was.
How are we gonna measure that? Like with what?
We're going to use a pen or a pencil and stick it in the crater hole, and then we're going to use a ruler and measure it out.
Okay. What? Okay, you're not doing that in the right spot. This question is all on the back of the page, of that page, I think. Yeah.
Okay, then we answer it in number 2.
Yes. That's great. I spelled we wrong.
What's on the back of your hand?
White out. Because Lizzie puts it on me and stuff stays all the time. Then we will use
This video is gonna be because there's just me so like talking outside.
Okay, then.
25 meters. Are you gonna read your answer to them?
Sure. So I said we are going to drop a marble from different heights using the measure of meters, adding 0.5 each time. To measure the depth of the craters, we are going to put a pencil in the crater hole and measure the pencil
In order
that
to
has
get to
flour
this experiment, I'm going to rush you a little bit. It's time to start collecting your materials. Okay? So to review, you've got these materials that you need. In order to do 5 drops, grab 5 marbles per group so that you can just 1, 2, 3, 4, 5. Those of you measuring ejecta, you'll have to pause in between. Leave the marbles in there. Don't retrieve them until you're ready for your second independent variable. Yes, sir?
Don't we need to drop the marbles in the exact same spot to get proper results? We could just do it in different places at a time with the different how we eject it.
You're going to measure from the hole to the furthest out ejecta. Will that make sense? Okay. Ready, go.
Okay, I will get 5 marbles.
Okay.
Okay, but make sure that we like shake it.
Yep.
Never mind, I'm not
Just place it on the floor. Okay, do you have your binder and paper, a pencil, spoon, note card, and 2 worksheet?
Oh, I didn't grab the marble.
Yeah.
We did this a couple weeks ago for our class, and it was weird.
Okay, I have 5 marbles.
Should I like tilt this? Do you think I should tilt this down?
Yeah.
The basin?
Probably.
Alright.
Send my face to it.
They look about the same though, Kayla.
Oh, thanks, Priya. Okay, so we're shaking up this, then all the flour is light. Wait, what's that word that we get now? Sifted. Okay, so, and then we're gonna go up 0.5 meters every 5 minutes.
Yeah, so let's do this. Okay, so find half or meter.
Oh,
Sorry,
Priya.
Go up.
It's
at the top
upside down.
here.
Is it 15.25? Yes, it is. It's so upside down. Okay, so we're gonna go on top of the bowl. Yeah, we're gonna drop it at 50 meters.
50? Right there. Okay, ready? Oh my god. 2. 4. And the last one, 5.
Okay, so now we're gonna. That was trial 1, so now we're going to take.
That was all 5 trials.
Okay, but it was the first thing.
I'm just gonna sit here with my camera. This is what my life has come to.
Show him Leah's paper while Leah writes.
Okay.
And then, yeah.
So this is what the paper looks like, I guess.
Okay.
Okay, so we have pencil. Okay, so here
That one
can
was this
see
long.
how deep it was by how much flour it is covered in. And so then we're gonna take it to here and we're gonna measure how much it was.
This would be so much easier with an actual camera.
Looks like it's about 2 meters.
So trial 1 was 2 meters.
Point.
0.2.
Hey, Miss Rudd. If it was right there, would it be 0.2 meters or 0.02?
2.2. No, I'm sorry. 2.2 centimeters. So 0.02. 0.02. Yeah, because it's 100. We'll take 99 centimeters. So 0.99 for. Yeah.
Yeah. Thank you.
So
I think this one was the deepest.
Okay, so let's pull out the ones we did. Should be just this one.
hey,
You can't see it.
this is my nice sweatshirt. Don't be white.
Did you say don't be white?
Yeah, don't be white, Caitlin. That's about 2.
Looks like it's
Little
just a
over.
little over 2, so maybe 0.022.
Okay. 0.022.
So were all those dropped from the same height?
Yes,
They're all dropped from 0.5 meters.
Was it how many you measured then?
just 2.
2. And were the numbers pretty close?
Yeah. This was only.
You guys got
0.002.
flour on the computer.
Like I meant to.
They got flour on the computer.
This
Stop
one's
wiping that on my
Okay,
sweatshirt.
this
Is
one's
this
done
spoon
getting
under
out
you,
here.
Kriya?
Yes, I'm sorry.
Want to use mine?
I'm glad I got all my homework done.
For this?
No, for math class. So there was.
Okay, we're just short of 2. So maybe 0.
0.18.
Yeah, I think I would agree with that.
Whoa! Oh, that's gross.
Did you take that one out? Wait, which one did you measure? This one?
Yeah, that one. We still have these 2 left.
0.01.
And once we're done with this, we can put some butter and eggs and sugar in there, make some brownies.
Oh my gosh.
So here's the next one. This one. Okay, it looks like it's about 0.015. You see the line there?
0.015 meters.
Is that the shortest so far?
Yes. And I kind of saw that too when we dropped that one in. It looked like it was up farther than the others.
Those look like eyeballs. Stop wiping it on my sweatshirt.
Okay.
Stab through the eye.
With a fork?
No, I was gonna say a bad word.
Oh, this one's the farthest down. This is 0.025.
Yeah. Kaylin, I swear to God.
0.025 meters. Okay, and then we're on to
Then we're gonna find the
independent
average.
variable. How do you find the average? You just add them with the mean.
Oh, sorry.
That should be the average. Just
Don't pack it too tight.
Just double check.
This is red.
Oh, it smells good.
This is red. In order to find the average, we have to go up and divide by how many numbers we have.
We'll do that tomorrow.
Okay.
Just get your drops in.
Okay, so now we're gonna do just 1 meter.
Are you gonna drop them?
You can. I'll hold it. So it's gonna be all the way at the top.
Oh, should we redo that?
I would think so, because I think it's
Yeah.
invalid, isn't it?
Do we need to redo both of them then?
I think you'd have to.
Yeah, because we touched it then.
Maybe I should stand up. Should we try and cover that back up or no?
Nah.
Just don't drop it.
So get on the chair.
I thought you were gonna hit me with that one. I apologize for the quality of this video. It's probably not gonna be that good.
Okay, I'm gonna make a prediction because I'm a genius. This one's gonna be this.
Okay, so this time it's only up to there. It's about 0.015 again.
This video's gonna have a lovely soundtrack.
I know, right? It's great. Here, I want to do the.
Okay. Do that.
Leah.
That's like exactly on 2, so 0.02. That was this one?
Yep. Is there a marble right there?
Yeah.
It's a little over 2.
Yeah, I'd say 0.022.
Didn't we have that one? Yes. 0.022.
I'm gonna ask you to finish this one trial and then bring your materials back to where they belong.
And that
We're
was
gonna
this
run out
one.
of time. We'll continue tomorrow. We'll pick up exactly where you left off. Monday. Sorry.
That's like 2.5.
Yeah, I'd say
0.025.
Yep. That's this one.
Oh,
It was?
Yeah.
I thought I already measured. Can you see where that is and where the flower already was?
Well,
just a little over half, so about 0.026.
Yeah.
I mean 0.0.
Want me to grab it?
Yes.
Are we gonna continue?
No, we had to finish. Yep, once we were done with that trial, we had to be done.
I just got that all over my leggings.
Leah has flour all over. I don't have any flour.
No, I should only let it
Dude, Leah, why you gotta be so
Hey, one of you show the sheet to this.
You can do that too, better handwriting.
Here we go. That's what they did. Should I stop the video, Miss Red?
Yep.
Okay.
Thank you.
Yep.